Welcome to our Systems Approach lecture series on 5G mobile networks. You've undoubtedly been hearing a lot about 5G and its promise in the popular press. In fact, probably so much information overload that it's been very difficult to separate the hype from the reality of 5G. What we're going to be doing in the Systems series approach is trying to break 5G down into its elemental components and explain how those components are being put back together to build the 5G mobile network of the future. We're going to get started with an introduction, introducing some of the basic terminology and ideas, and just setting the stage for the deeper dive that we'll do in future lectures. So at a high level, the important thing to understand about the mobile cellular network is that it is the access network of the internet. It is the last mile that connects end users and their devices to the internet backbone. Now the internet backbone spans the entire globe, and it's that connections at the last mile that we're talking about here. There are many technologies here, other technologies like fiber to the home, passive optical networks, and Wi-Fi, for example, are all of that set of last mile networks. But again, we're going to be looking at the mobile cellular network in this case. Now, if you're a telco that offers a service like this, you basically have many points of presence throughout a country or the world where you're aggregating all of the cellular network base stations. These aggregation points are quite often called central offices. Just introducing some of the telco words that we'll be using throughout the lecture. So the history of the cellular network actually parallels the 40-year history of the internet. And I will emphasize parallels because they've been two largely independent technologies and standardization processes. So the first two generations of the cellular network introduced first voice and then text services, and then with the introduction of 3G, neighborhood of 20 years ago, was the introduction of broadband data service. Pretty low bandwidths, but it was at least broadband data connectivity to your cell phone. 4G improved the broadband rates to a few megabits per second, and 5G now has the promise of improving those data rates yet once again. But 5G is about much more than just improving the data rates, as we'll see in a little while. Now, at the same time it's such an important technology, it really remains largely opaque to many internet-centric, cloud-savvy people, developers and users. You may be very familiar with the IETF and its processes of standardizing the internet technologies, but there's an entire, again, parallel endeavor standardizing the cellular network. The key standardization body is 3GPP, which is third generation partnership project. Started with the introduction of 3G. It's the same name. It's got the 3G in it, even though it's now standardizing 4G and 5G. Turns out 4G and 5G are really kind of marketing demarcation points. What the 3GPP has done is just introduce a series of releases of the standard definitions, 1,000-page documents defining the cellular network standards. As we went from release 14 to release 15, that was really the demarcation point between 4G and 5G. 16G at the time of this is now release 16 is now out there, and release 17 is to be published in 2021. Each generation is demarked by 3G, 4G, 5G is roughly a 10-year evolutionary path. In fact, you may know of LTE, that's just a synonym for 4G, standing for long-term evolution. But evolution is continuing here in 5G. In fact, as we talk about the promise of 5G, this is really the beginning of that 10-year period. So much of it is still anticipated, but at least we will get a look at where things are going. The other thing about this remaining opaque is that the implementations are largely closed, proprietary, and bundled. Yes, you can dig through thousands of pages of standardization documents, but it's really difficult to understand exactly how all these parts can and do in fact in practice fit together. The implementations are closed, they're proprietary, and the standards really only tell you so much about what the reality is. So what we're going to be doing is kind of trying to peel back the covers on all of that, looking at, again, we're going to break 5G down into elemental components. We're going to disaggregate this particular access network, and then we're going to show how it can be put back together. Now, I mentioned that 5G has goals far beyond just higher speeds. And so I want to talk about what some of those are. First one, of course, is higher speed. So this is generally referred to as enhanced mobile broadband, that in any geographic region, you get high capacity, high aggregate capacity, and then to any one end user device, you will get multi-gigabit per second peaks and sustainable bandwidths of 100 megabits per second or more. So high bandwidth is absolutely still one of the goals. But beyond pure bandwidth, the second objective is to support massive Internet of Things, and the key word here is massive. We're talking about potentially extremely high density devices, upwards to 1 million nodes or user devices of one kind or another per square kilometer. So that's very high density. These devices are going to be intermittent in their transmission, unlike a typical broadband connection today. They're going to be very low energy devices, and so they want to use their batteries. They're going to be sending very small amounts of data very infrequently, but that's a completely different model of communication than has typically been supported on the cellular network. 5G is going to be extended to better support that sort of use case. The third big high-level goal for 5G is mission-critical control. And this is basically getting at very predictable, very reliable, very low latency communication that one could depend upon to control cyber-physical devices, for example. So ultra-low latency below a millisecond is an example of that. And all the while there's extreme mobility, that the devices are moving throughout the network much, much more quickly. So these are independently extremely aggressive goals, but trying to achieve them in aggregate makes the problem even more difficult. And again, this is the long-term 10-year plan. We're certainly not going to do this at the start, but from an architectural point of view, we need to account for all of these dimensions as we think through how 5G is coming together. Now, I've been focusing on the communication aspects of 5G, but 5G actually is happening at a time that the cloud is evolving as well. And so we really have to take the communication aspects and think of them at the same time we think about the edge cloud. So what is the edge cloud? Edge cloud is simply about moving functionality from data centers to the edge. And by the edge, I mean close proximity to end users and their devices, their autonomous vehicles, their drones, their kitchen appliances and whatnot. We're moving computation that used to be in data centers tens of milliseconds away, much, much closer to the edge. Now, I'm not going to go into all of the arguments behind this, but there's a set of applications that would value that kind of close proximity. Certainly in the immersive user interface realm, having to do with virtual reality and augmented reality. I've mentioned Internet of Things, massive numbers of devices of various kinds, so it's no longer the human connecting to the internet, it's devices connecting to the internet. Autonomous vehicles, autonomous, perhaps multiple coordinated robots and drones. These are all just examples of the kinds of applications that are going to require something a little bit different than traditional data center computing. They're going to require very close proximity, very predictable latencies, and very high aggregate bandwidth to the edge. And that's basically the impetus behind the edge cloud. Now that's happening somewhat independently of 5G, but it turns out that if you ask the question, well, now where is the edge? Then the very central offices that implemented the access networks that are the aggregation points for the 5G mobile network are one very likely place that the edge cloud could be implemented. They are physical points of presence. There's real estate. Large carriers like AT&T have thousands of central offices across a country the size of the US. Those are very obvious places to put points of presence for the edge cloud. It turns out that these telcos have been re-architecting and reimagining their implementations of their central offices for the last several years now. And what they've been trying to do is to bring the best practices of building scalable clouds to the central office and therefore to the telco last mile access networks. What I mean by cloud tech best practices include commodity servers and white box switches. It includes cloud native software, microservice-based Kubernetes, for example, type software, and agile engineering processes. Very different ways of designing the access network when you compare it with the closed proprietary bundled access networks that we've been talking about in the recent past. So, telcos where the 5G network is being implemented is a place that the edge cloud could also be implemented. And in fact, like I said, the telco has been working on this for a little while. and they have a technology that's generally referred to generically as CORD, Central Office Re-Architected as a Data Center. The name kind of tells you what it's about. It's about bringing cloud technologies like what you can basically think of as a Kubernetes cluster that hosts a mix of access services and edge applications in the central office. And we're going to use CORD, which is an exemplar reference. There is a reference implementation of CORD. We're going to use it as an exemplar for describing the implementation of 5G as we work through the details. Now, while CORD was originally conceived as a telco notion that telcos could build small data centers that implemented access network technology and these edge services like Internet of Things and augmented reality and so on, it turns out that once you build that technology, it's not limited to telcos. It could be placed anywhere. It could be placed on campus. It could be placed in enterprises. And in fact, an enterprise edge cloud that has been 5G enabled is an example outcome of everything that I'm talking about. So it's the 5G transition happening as the edge cloud happens. It comes together not just in technology that could be deployed by telcos that have been the operators of the access networks, but it could be then deployed in fact inside of enterprises. So this is kind of a high-level conceptual diagram of what that would look like. Focus in the middle first focus on the edge enterprise. There'll be a cluster. Let's think of it as a Kubernetes cluster that's running some combination of services that are connected to the cell towers. Let's assume they're small cell because we're inside of an enterprise. CBRS is the Citizen Band Resource Service, radio service, which is basically some bandwidth set aside for use to offer 5G services, not unlike the Wi-Fi band is set aside for setting up Wi-Fi. So it's basically open or lightly licensed. It's not entirely unlicensed band, but it is lightly licensed. And it's quite likely that enterprises, and think of university campuses as a great example, will set up their own CBRS networks, just like they set up their own Wi-Fi networks today. And then connected to those services, or to those small cells, will be everything from IoT devices to surveillance to your cell phones and so on. Now, this edge is still operating as part of what is as we will see, is a fairly complicated cellular network that has a centralized component to it. And so we're going to put that centralized component back in the central cloud. And so the question then is, how do we take the 5G cellular network and distribute it across all of these elements? And so I'm going to give you just a really high-level, coarse-grained description of that here, and there's much, much more subtle detail to all of this. But the first general concept is we're going to take the control plane for the 5G network, and we're going to put it in a central cloud somewhere, and we're going to give you a portal so that you can manage it as an enterprise. I'm showing one enterprise here, but in fact there could be many, many enterprises. And they're all managed from the same central cloud. So we put the control plane in the central location, and then we put the data plane at the edges. And the way that you can think about this is that this distributed data plane provides a local breakout at every edge site. So instead of having to go back all the way to where the central office used to implement the access network, I can get to it locally within my very own enterprise. And that's presumably going to be much, much closer. All the while, I can still control it from the central cloud. In fact, I could control it from a commodity cloud like an Amazon cloud or a Google cloud or Microsoft's Azure cloud. Now, I'm using the terms data plane and control plane in a very general sense here that you might be familiar with from networking. This isn't quite the way that the 5G folks talk about it, so we'll come back to that. But I think this gives you the general idea. Once you have broken out the data plane at the local enterprise, then not only do you have the opportunity to run traditional central applications in the cloud, you now also have the ability to run the edge applications, whether they're native edge or they're accelerating something that used to happen centrally, at the edge. And hopefully what you can see here is that because of the local breakout, I get through the local breakout through the data center, the local data plane back to the edge app without ever having to leave my enterprise. It's as though bits of the cellular network are now literally running locally. So what I've just described here is in fact a very high-level roadmap of what we're going to do as we break down 5G and put it back together again. We're going to put it back together again, not in isolation, but we're going to put it back together as part of an enterprise edge cloud. And it's that combination that will be interesting to us in the long term, because the end value proposition of 5G is not just the higher bandwidth, not just the massive Internet of Things, not just mission critical control, but it's all of those things coupled with a very integrated embedding in the cloud. So you can think of the access network as not just extending the cloud now subsumes in many respects the access network. And that is a very qualitatively a important change that is coming down the pipe.